This is a 2016 AP Calculus free response number 2. It says, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by the function v of t equals 1 plus 2 sine of t squared divided by 2. The particle is at position x equal to 2 at time equals to 4. A says, at time equals to 4, is the particle speeding up or slowing down? Remember, to figure out if it's speeding up or slowing down, you have to check both the velocity at 4 and the acceleration at 4. And then you compare their signs. If it has the same signs, it's speeding up. If they have the different signs or opposite signs, then it's slowing down. You can use your calculator for this. I've already entered my equation into y1. So v of 4 is going to be y1 of 4. And then this is v of 4. And my acceleration is the derivative. At 4. Okay, so v prime, which is a of 4, is going to be negative 1.164. Okay, so v of 4 we found to be 2.978, and a of 4 was negative 1.1640. Since they have opposite signs, the particle is slowing down. The particle is slowing down because v of 4 and a of 4 have different signs. Okay. The scoring guidelines for A is 2 points. So 2 points for the conclusion of it slowing down with different signs. Okay, B. Find all times t in the interval from 0 to 3 when the particle changes direction. Justify your answer. So when the particle changes direction, okay, if it says it's moving along the x-axis, think about your x-axis, okay? So it's going right, left, right, left. It's going back and forth, right? So at the time when it changes direction, it's a what we would think maximum or minimum, or what we would say maximum or minimum. So when the particle changes direction, that is when v of t equals to 0. Going back to our graph, okay, and remember the window is from 0 to 3. So we're going to go ahead and change our window. And we are looking for when v of t equals to 0, basically where it crosses the x-axis as zeros. Okay, it only changes, only crosses there, so let's go ahead and find the 0. Oops, my bad. Okay, so the 0 is at 2.707, and notice that it goes from a positive to a negative. So because it changes sign, it changes direction. So at v of t equals 0 at time equals 2.707, since v of t changes signs, we know that since v of t changes signs, the particle changes direction. All right, so the score for that one is 2 points. 1 point for finding 2.707 and 1 point for the justification of how do you know that that's where the particle changes direction. Well, I know it's because that's when v of t changes signs, and it's when v of t equals to 0. Okay, C. Find the position of the particle at time equals to 0. Keep in mind that at time equals to 4, the particle was at x equals to 2. So to find the position, which is x of 0, remember that x of t is typically the position, the notation for position of the particle, x of t. So at x of 0, we have to consider the initial condition, not the initial condition, it's the position where it was at 4. And then we have to figure out how much did it travel. Since if you think about the timeline, okay, if you think about the timeline, if at time equals to 4, it was at 2, and I want x of 0, I'm actually going backwards. So I'm going to integrate backwards from 4 to 0. So my integral from 4 to 0 of v of t dt plus the position of the particle at time equals to 4, which was 2. Okay, so I have 2 plus, when I integrate this, it's going to be negative 5.815, 0.27 if you don't round. So that's going to be negative 3.815. Okay, so x of 0 is negative 3.815. Okay, and the score for that is 3 points total. 1 point for the integral, 1 point for the initial condition, the x of 4 equals to 2, and then 1 point for the answer. So it's very important that you look at what they give you. They give you that x of 4 equals to 2, and because I want 0, you're going backwards. That's why my limits are from 4 to 0, not the other way around. Okay, be careful with your limits. Okay, and last one for number 2 is D. Oops. Find the total distance traveled. Find the total distance the particle travels from 0 to 3. Okay, be very careful when they say distance. Remember that distance is the absolute value of displacement. Okay, so if I'm going to find the distance from 0 to 3, I'm actually finding the absolute value of v of t dt. On your calculator, okay, so on my calculator, since I already have the equation here, you have two choices. You could either put on the second line absolute value, and to find the absolute value, you're going to, let me just go this way a little bit. It's going to be under math, and then right here number, go to the right, the first one abs, and then since I already have the equation in y1, I'm just going to put absolute value of y1. Okay, that takes care of it. And then I'm going to go ahead and quit. Okay, and then I'm going to find the integral, so math 9 from 0 to 3. And remember that I want y2 because that's the one that has the absolute value in. And then dx. It's going. Okay, 5.3. So the distance traveled by the particle, let me go back now. The distance traveled by the particle from 0 to 3 again, distance is the absolute value, is 5.301. And there's no units, so don't put any units. If they give you units, then you would put units. Okay, and the score for that one is 2 points, 1 point for the integral, and 1 point for the answer. So if you set it up correctly with the absolute value and the limits, that's 1 point. But you have to put absolute value because it's talking about distance. And then 1 point if you calculate it right. Okay, that's the end of number 2.